In this demonstration, you will see a table constructed to replicate various scenarios when applying pesticides. We will spray water for safety purposes, but the same concepts relate to pesticides you apply in the field. The demonstration includes a comparison of volume output with different nozzle sizes, variations due to nozzle type, the effect of increasing pressure, how a damaged nozzle can impact application, and the effects of boom height and drift. Careful consideration of these factors will maximize crop protection, reduce input cost, and reduce environmental impact. By the end of this video, you will be able to describe the impact of nozzle size and type on pesticide application, explain the effect of nozzle damage on pesticide application, explain how pressure changes impact pesticide application, describe how boom height influences spray patterns, explain how to avoid drift when applying pesticides. The first demonstration compares the difference in applications with two different nozzle sizes. Both nozzles have the same spray pattern, but one has a larger orifice than the other. Now that the nozzles are attached, the pump will be turned on to begin the test. As demonstrated by the water collected in these tubes, the output volume varies based on nozzle size. The larger nozzle has a higher output than a nozzle with a smaller orifice. Choose nozzle size based on application rates and label guidelines. Different nozzle types can be selected for various application needs. Nozzle type can be used to alter spray patterns for either a banding application or a broadcast application. The goal of banding is to apply pesticides only to the row crop and not in between rows. When banding, an applicator does not want spray patterns to overlap. For a banding application, an applicator would select an even flat fan nozzle or other nozzle that produces a spray pattern with no overlap. For a broadcast application, where uniformity is the goal, a certain amount of overlap may be needed to achieve an even application across the field. Recommended overlap varies depending on nozzle types and nozzle spacing. Nozzle recommendations are unique to each product. Read all labels and instructions prior to applying any pesticide. Another way to change an application rate is to adjust the pressure. In this demonstration, we will start with a pressure of 15 pounds per square inch. From the 15 psi setting, this is the amount of water collected in the tubes. Next, the pressure will be increased to 60 psi. A higher volume of water was collected in the tubes when the pump was set to 60 psi. Looking at both tests side by side, we can see the difference in volume output at 15 and 60 psi. By increasing pressure 4 times, the amount of water output from the sprayer essentially doubled. While increasing pressure increases the output volume, it also decreases droplet size. A pesticide label will typically recommend a droplet size and an appropriate range of pressures for application. These are important to maximize effectiveness of the pesticide. The next demonstration will show the differences between a damaged nozzle and a new nozzle. Nozzle performance varies greatly between new and damaged nozzles. Damage can change the diameter of the opening, which affects your application rate. Sometimes people will attempt to unplug a nozzle with a wire or nail. Trying to clean a nozzle with a wire or nail will likely ruin it. If you need to clean a nozzle, consider using an old toothbrush or something else that is softer than plastic. This close-up shows a damaged nozzle. When using nozzles, a certain amount of wear is unavoidable. For example, a wettable powder is more abrasive than an emulsifiable concentrate. As the wettable powder comes out of the nozzle, it can wear on the orifice edges. Inspect nozzles frequently to ensure that they are in good condition. Using damaged nozzles can lead to an uneven application, increased input costs, and damage to the crop. Boom height is another factor that can affect uniformity of spray application. Spraying at the current boom height results in a fairly uniform overlap, exhibited by the water distribution, particularly at the center of the table. Now the boom height will be lowered while spacing between the nozzles remain the same. The lower boom height results in a spray pattern with 2 separate peaks and an uneven application. The benefit of a lower boom height is reduced drift. Selecting nozzles with a different fan angle and adjusting pressure can improve application uniformity when using lower boom heights. Drift is a valid concern when applying pesticides. Drift can lead to ineffective control of weeds or insect damage and damage to non-target organisms. A fan has been set up to demonstrate what happens to a spray pattern when it's windy. In this demonstration, the wind from the fan caused the water to drift to the left, producing an uneven spray pattern. Uneven spray patterns can potentially damage a crop or non-target organisms. To reduce drift, do not spray when the wind is 10 miles an hour or faster. Following all mixing and application guidelines on the product label will also reduce drift and maximize effectiveness of the pesticide. This demonstration illustrated the effects of several factors impacting pesticide applications, including nozzle size and type, pressure settings, nozzle damage, boom height, and drift. While these factors may make spraying pesticides a complex process, being mindful of them will help ensure maximum crop protection, reduce input costs, and reduce environmental impacts.